Okay, good morning, everyone, and thank you for joining us in today's knowledge sharing event on the economic impact of weather shocks on a cold climate developing economy evidence from Mongolia. So it is exactly 10:01. So we can see that many are already connected online. And then for those who have joined us here in Knowledge Hub, thank you for coming. At the back, we have our snacks prepared. So anytime you can get and then come back to listen. Thanks. So this knowledge sharing event is one of the six events lined up for the Resilience Learning Month, where key and emerging topics on climate and disaster resilience and environmental sustainability are featured and shared with wider audience. So for these events, we have our authors here who did the research, and they will present the initial findings of their research work where they tried to examine the economic effects of weather shocks in Mongolia and investigates the differentiated impacts of climate shocks across sectors and provinces. And as we all know, Mongolia faces warming rates far higher than the global average, and the changing precipitation pose challenge to the country, especially to climate sensitive sectors. So basically, this study aims to contribute to existing literature on climate impacts on cold region economies, which currently is quite limited. So this event has two parts. The first part will invite our three authors, our three speakers to present their findings. And the second part, we have invited two discussants to share insights and their perspectives with regards to the findings of this research work. We will also devote a Q&A part towards the end of the session. So if you have any questions for those connected online, you can put in your questions at the chat box, and then later we'll try to address all those comments or questions. So to officially open the this knowledge sharing event, I'd like to request Kelly Bird, advisor to the East Asia Department, to give us opening remarks. Kelly?
Thank you very much, Sugar, for the introduction, and thank you for joining this event this morning. And also for those who are online, I think we've got well over or close to 20 online, and a lot of them are from our colleagues in the Mongolian resident mission. So welcome to this presentation. I just want to say a few words. First of all, I want to congratulate Dottie, Homer, and Kara for high quality knowledge product that they've generated and for collaborating. So Dottie's works in the East Asia department, but Homer is in CCSD PARD, and Kara is on a short-term assignment in the resident mission. So it's great to see, and she's from PARD, right? Kara's from PARD. So it's great to see this cross-departmental collaboration on knowledge. I did go through the paper, and I had the privilege of getting the presentation in advance, and I think it's an excellent presentation, well communicated. So I really enjoyed looking at it. Also, I want to say is that, you know, this is part of East Asia's department shift on knowledge. We've done a lot of knowledge in the past, but going forward, we want to generate knowledge products that are evidence-based, that are looking at very pertinent issues that are and challenges that are faced by our member countries, and also importantly to help inform us about these relationships, and particularly on climate. There's a lot of, you know, when we go talk to governments or stakeholders, we don't want to go in talking blind about what so-and-so said. We really want to go there and talk to them with evidence on hand. We want to be able to explain to them what we think is the relationship between climate change and the impact that it will have on their economy, society, and communities. And I think this paper is a good example of that, because it really is, in a very robust way, establishing relationships between temperature, rainfall, and economic growth and production across different sectors. And when they do present their presentation, you'll see that it's incredibly complex. There are some sectors that benefit from increase in rainfall. Some sectors don't. Some sectors benefit from increase in temperature. Some sectors don't. It also varies across provinces and at the national level. So it really is a complex relationship. But understanding these channels and transmission channels are important for us as we prepare projects, and we also engage in policy dialogue with government. Now, when it comes to climate, Mongolia, ADB is preparing a policy-based loan on climate action. It's been in preparations for 2 years. We plan to have that going to the board for approval. I think it's November. It looks at improving institution coordination. It looks at finance, and it also looks at how do we do structural reforms in those sectors that are important to climate. We've got energy and agriculture. So this study fits very nicely into what we're trying to do on climate. It also will help inform our next country partnership strategy that's under preparation for approval next year. And I hope this also helps to inform the direction of what kind of projects that we should be investing in with Mongolia. I'm going to leave it here, but I also want to thank the two discussants. It's Ed, who's the country economist in Mongolia, and Inki, who is our environmental specialist in Mongolia as well. So I'm really happy that they will be providing their country and expertise insights into this paper. So once again, thank you, Dottie, Homer, and Kara for an excellent paper and for the presentation. I hope you do have a good interaction with the audience. Unfortunately, I have to go to another meeting in a few minutes, but I really wish I could stay to listen on. But once again, thank you very much.
Thanks, Kelly, for that very encouraging message to our authors. For our proper presentations, I'd like to introduce to you our first speaker, Homer Pagkalinawan. Homer is a climate change officer of the Climate Change and Sustainable Development Department. He recently joined CCSD as part of the Pacific Climate Team and Climate Focal for Palau, Marshall Islands, and Federated States of Micronesia. Prior to CCSD, Homer was with the Economic Research and Development Impact Department. So in his presentation, Homer will try to give us some background on Mongolia's climate trends. Homer?
Thanks for that introduction, Sugar, and thanks again, Kelly, for the nice words. So as mentioned, my part will be focusing on the data that we use, in particular the weather data that we use, which we're hoping you can have some inspiration if you'd want to replicate to other countries and other economies as well. Yeah, the author, so we're one ADB empowered. Dottie, our main author, is from East Asia. I'm from CCSD, XERDI, and we also have Kara, who's from PARD, who's joining us online. Hi, Kara.
Hi, Homer.
So let's start there. So there's Kara. So let's start with the motivation behind the research. So back in 2015, Berkshang Miguel published this global nonlinear effect of temperature and economic production. So this is a widely cited paper. So essentially what Berkshang and Miguel is saying is that the effect of temperature is nonlinear, essentially an inverted U parabola, wherein country level gross domestic product, which is the one along the y-axis, is increasing until you reach the optimum of 13 degrees Celsius. And then after that, the GDP of a country or economy goes down. And such that since it's the cold country that increases production as temperature increases until the optimum, which is 13 degrees Celsius. Okay, so that portion on the left side of the parabola. However, please take note that the relationship is not entirely causal, meaning not because your temperature is lower, your productivity is also high, is higher. Now let's give a context in terms of where the developing Asia Pacific countries are located in this curve. As we know it, temperature is dependent on how far you are from your equator or your latitude, such that our tropical countries from the Pacific, South and Southeast Asia will be mostly on the right side of the curve. On the middle will be the Caucasus and Central and East Asia, as well as the mountainous South Asia, Bhutan, and Nepal. So again, each point on the curve is a country, 166 countries as input from their GDP is from 1966 up to 2010. And lonely on the left side of the curve is Mongolia. And this particular relationship was further supported by the findings of Acevedo in 2020, wherein they emphasized that it's the hot countries which are mostly low income. We could sometimes refer to them as the global south, and they suffered the most from an increase in temperature. So again, if you have increase in temperature, either you also have a low capacity to adapt with the changing climate. So with that, we have an idea that there could possibly a research gap that we could fill in. So most of the research would focus on the economies that are on the right side of the curve. Now we'd like to take a look at those at the left side of the curve. So why Mongolia? Mongolia, again, based on the map earlier, Mongolia is the coldest among the developing member countries of the Asian Development Bank. It sits at a 0.4 degree Celsius average annual temperature from 1901 to 2023. Thus, our objectives mainly for this research is to conduct a localized study for Mongolia and cross-check the application of the previous findings by Berkshire and Miguel and Acevedo. How does it apply in a local context for Mongolia? And ultimately, since we're also doing country and sector-specific impacts of climate change, it's all about creating an informed forecasting for the macroeconomics of the country and the support, the policy. Again, as mentioned by Kelly, country CPS of Mongolia is coming up. So we're hoping to use the findings of this research as input for the upcoming CPS. Okay, so just a background on the physical and the climate in Mongolia. Again, it's located between the 41 degrees and 53 north latitude. Average annual temperature 0.4. In terms of precipitation, it's of course in the country where this is much less in terms of for tropical countries, about 250 millimeters. And then its climate is highly affected by its topography. It's landlocked, meaning no oceans adjacent to it. And it has large variations from very cold winter and long hot summers. And again, its elevation of mountains at rolling plateaus with an average elevation of more than 150,000 above sea level. The one on the right, so this is already a preview of the data that we use. It's called a monthly gridded data. And as you can see, it changes from January 2021 to December 2023, wherein as you go to the year, it becomes lighter, meaning the temperature becomes darker. So again, the range of temperature for that particular graphic is from negative 33 degrees Celsius, which mostly observed during the winter, and it can be as hot as 30 degrees Celsius during the summer month, which is still ongoing, I think, for Mongolia. So again, just to give a geographic context, Ulaanbaatar is the one on the middle top of the map. Okay, so who here are familiar with Zud? Okay, so how about those from the tropics? Are you familiar? So yeah, so actually when we started researching on Mongolia, this is also something new to me. So Zud is actually a Mongolian term for a very long winter. So as you can see on the image, Zud is kind of unique with those economies with continental climate. It is characterized by a cold season disaster, actually not just cold, a long cold season disaster. So you can see on the image on the right-hand side are herds of livestock. So imagine it's a long winter and it's supposed to be spring already. You'll be supposed to find new foraging ground. But due to Zods, it's a prolonged winter, so no new foraging grounds are available for them to feed on. And that will lead to their perishment and loss of business and livestock for the nomads who are raising these herds. Okay, it can also lead to reduced accessibility. So of course, if you have long winter, more precipitation, and then availability of pasture ground. And the severe ones are associated with high mortality of these livestock. Not just livestock, of course, the people are also affected. And it also affects the growing patterns of the plants during the following spring. And Zuds are usually it also coincides with a very low temperature. You can see here the graph showing the temperature from 1901 to 2023 for the temperature for the whole of Mongolia. And speaking of the most extreme zods, we have a recent one just this early this year, early last year after early this year. They caused 7.1 million livestock to perish, which is already equivalent to 1/10 of the entire livestock herd of Mongolia. So 1/10 were lost during the long winter period. And then other recent major zods are in 2016 and 2009 and to 2012. And there's also an anomaly on how frequent a zods is occurring. So before they're expecting once or twice per decade, but now zods are happening more frequently according to. Okay, so since I mentioned about ZODs, would like to also introduce how were we able to monitor, incorporate the ZODs in our study. So we use the data from MDAT, or the Database for Emergency Events or International Disasters. And then aside from that, the temperature and precipitation were sourced from the University of East Anglia Climate Research Unit. So again, these data sets are global. Whatever we did for Mongolia can still be replicated for other economies if you also have possibly an upcoming CPS. And with that, so that's about the climate and physical environment of Mongolia. I now turn you over to Sugar for Kara. Thank you.
Thanks, Homer, for that very good background on climate trends in Mongolia. Our second speaker is Kara Tinio. Kara is an Associate Economics Officer of the Pacific Department. Currently, she is on short-term assignment in Mongolia Resident Mission, where she is supporting economics work and country operations, including preparations and inputs to the forthcoming Asian Development Outlook and country partnership strategy. She also continued to contribute and coordinate ADB's economics work and project economic analysis in the Pacific sub-region. For this second presentation, Kara will present to us the economic structure and vulnerability to weather shocks of Mongolia. Kara?
Thank you, Sugar, and thank you as well, Homer. So very brief overview of the economy of Mongolia. As you can see on the right side of this slide, we have a breakdown from the past 5 years, 2019 to 2023, of the economic structure of Mongolia. The largest section, the blue section in the bars, that's represented by services. The next largest in terms of percentage of GDP would be mining here in the orange. And it must also be noted that, of course, services is one of the sectors that's somewhat tied to mining output as well, in terms of course, transport of the products to the border where they are exported, as well as related financials and other services. Finally, in the green section at the bottom of these bars, that's the agriculture section, and we will discuss a bit more about the climate sensitivity, particularly of agriculture, in a short while. So as Homer mentioned, there are very cold winters in Mongolia, and you might have noticed from this previous slide as well, the average annual temperature is 0.4% degrees Celsius. So, you can perhaps gather from this that the cold seasons can be very cold in Mongolia, as well as, they can stretch for a certain period of time. So even absent any climate shocks, under a business as usual situation with this prolonged cold season, economic activity can be somewhat limited. So, for instance, for mining, the ground may be quite, frozen. It may be difficult to extract resources from there. The weather can be quite inhospitable for construction projects, particularly, of course, for the critical, essential public infrastructure projects that, would provide more connectivity and such for, areas, especially outside of Ulaanbaatar. At the same time, for tourism, from my short time here, I am aware that winter tourism is it's a niche product that Mongolia is offering, but um, in times of prolonged cold, the window to visit destinations, particularly outside the city, it can be quite small, and there may be you might not be able to entertain quite as many visitors, even those who might be able to enjoy the cold weather a bit more. Um, so absent any climate shocks, you do have these constraints already from the prevailing cold climate here in Mongolia. Now, agriculture in particular, as we Homer discussed as well previously, it's highly sensitive to climate shocks. So uh, it accounted for maybe only a relatively small percent of GDP over the past 5 years. But we also note that it employs about a quarter of the workforce, particularly those outside of the rural areas, which heightens its significance, especially from a socioeconomic development perspective. And we also noted that because of the ZUD in 2023, um, that agriculture contracted by 8.9% year on year that year. And as Homer mentioned, there was a particularly harsh zud that occurred earlier this year, which caused the agriculture sector to contract again by a further 26.7%, quite significantly, in the first half of this year. So, climate we have tried to illustrate here that climate can um, be particularly important. It can have a significant impact on economic activity, particularly in the agriculture sector, the livestock sector, on which many rural Mongolians still depend. So that concludes my part of the presentation. We move on to the methodology of the study proper. Thank you.
Thanks, Kara. For our third speaker, we have Dorotea Ramizo, or Dottie. Dottie is an associate economics officer in East Asia Department. She is a seasoned economics researcher in international trade, trade policy, and econometrics analysis, with several publications in peer-reviewed journals. She is currently pursuing her PhD in economics dissertation at Curtin University in Australia. Um, Dottie will provide her presentation on the empirical evidence on the impact of weather shocks on Mongolia's economic activity and provide some policy implications. Thanks.
Thank you so much, Sugar, for that introduction, and to my co-authors, Homer and Kara, for the comprehensive and substantial context of what this paper is all about. So first, we discussed the macroeconomic variables that we use in our study. If you're going to see here, it is a mix of both national and provincial data and annual and quarterly data with a long time series. So given with our data structure, we're able to do both time series analysis and panel data analysis as well. So going for the methodology used in this study, we build upon the works of popular or well-accepted papers in this field, particularly the work of Acevedo et al. 2020, wherein we based our baseline pattern regression on the work of Acevedo to generate the dynamic impulse responses to weather shocks. So for this paper, I want to emphasize that the way we define a weather shock is a 1 degree Celsius increase in temperature, and for precipitation, it's a 1 millimeter increase in precipitation. So this approach captures the immediate or contemporaneous and long-term effects of weather shocks on Mongolia's economy. So now we describe this equation. On the left-hand side, our dependent or outcome variable, this represents the macroeconomic variables that I have outlined earlier, wherein y is the natural logarithmic transformation of the macroeconomic variables such as national GDP per capita, provincial output, quarterly GDP and sectoral outputs, and livestock. So H here represents the estimation horizon, wherein H equal to 0 is at the time of the impact or the contemporaneous effect of the weather shock. up to 8 horizons, which can be yearly or quarterly, depending on the data that we are using. And we are estimating equation 1 for each horizon. So I want to point out that the dependent variable here represents cumulative growth of the outcomes between horizons t minus 1 and t plus h, wherein h is the horizon. So if you will notice, if h is equal to 0, that is just the growth rate at the time of the impact. Okay, so that we are actually approximating the growth rate over the period of t minus 1 and t plus h. Okay, so on the right-hand side, our independent and control variables, we follow the framework of Burke et al., wherein we use quadratic specification for weather variables, both for temperature and precipitation, with one leg of the dependent variables. And this is a parsimonious model wherein we're trying to capture all other factors that can affect economic performance in Mongolia by using different fixed effect structures. So we know that Mongolia is heavily, like what Kara mentioned earlier, Mongolia is heavily dependent on minerals exports. And so we know that with its high dependence on mineral exports, it can be susceptible, highly susceptible to fluctuations in the global commodity prices. And so to account for that in our model, we use time fixed effects. And for the linear, we also include the linear time trends to capture the long-term economic changes in each provinces and reflecting shifts in productivity, demographics, and other local development patterns. And for nonlinear development or for nonlinear factors that can affect Mongolia's economic performance, we account for that using the quadratic time trends. So more or less, our model recognizes that there are other factors that can affect economic performance in Mongolia outside the weather variables, and we account for that using the time with the fixed effect structures. So for our national and quarterly data, we also used a quarter fixed effects to control for the predictable seasonal patterns within the year. For instance, we know that there are fluctuations in agricultural outputs, there are harvest season and planting season, and for instance, retail sales can also be seasonal in the sense that during holidays there are more retail sales. So we account for that using the quarter fixed effects. And our standard errors are clustered at the regional level to account for the possible correlation among error terms at the province level. So moving forward, we can actually get the impact of the weather shock based on the equation 1 by differentiating equation 1. And so equation 2, this represents the coefficients that we will be showing later on the impact of weather shocks to Mongolia's economic activity. So what we're doing here is we're getting the partial derivative of y with respect to the weather shock. Okay, now, so first we're showing, so first we want to show the effect, whether our results validate the inverted U-shaped relationship between temperature and economic growth that Homer earlier presented in the start of the presentation. So to be able to validate that in our results, the temperature and temperature squared should be positive and negative, alternatively, and statistically significant. But we're not seeing that results in our paper. So it means we're not validating the inverted U-shaped relationship between temperature and economic growth. And that is not really surprising because as we know, like what Homer showed earlier, Mongolia is at the left-hand side of the inverted U curve. So here we're also seeing that disaster is negative, but it's not statistically significant. And it's important to remember this result because later on we will see that disaster has a negative and statistically significant result on livestock, consistent with what Homer said on the impact of the Zods. So this is also the result of the effect on sectoral outputs. And again, we're not seeing the inverted U-shaped relationship between temperature and economic growth. But moving forward to livestock, zooming in on livestock, because as we know, livestock is an important sector in Mongolia, not just economically, but also culturally and socially, because a lot of its cultural practices are also tied to livestock raising. So we're seeing here that there is an inverted U-shaped relationship between precipitation and livestock, particularly when we include disaster. So throughout, it's quite robust that disaster, as defined earlier, disaster here is a broad definition, not just ZODs, but also drought, storm, and avalanche. It's very clear that disaster has a negative impact on livestock headcount in Mongolia. So we're capturing that what's happening on the ground is being captured by our results here. So overall, the key results, and I will be showing the impulse response function for this, is that a 1-degree increase in temperature reduces GDP per capita by 4.8% over 2 years and provincial output after 4 years. So there is a more persistent effect on provincial output for the impact of temperature on provincial level output. So, and for precipitation, we can see here that there is a positive impact on provincial level output, while livestock sector is more vulnerable to disasters, as I have shown earlier. And mining sector can actually benefit from higher temperature because, as Enki can explain later, that small scale miners can actually benefit from higher temperature because it's easier for them to extract the mines. And there is a divergent impact at provincial and national levels on the impact of weather shocks. So here's the illustration of what I'm saying. At there is a negative or impact on real GDP per capita 2 years after the shock, and more persistent impact on provincial output. So what is the difference? Why is there a difference on impact? And that is largely born because of the structural differences in the economies between national and provincial level. Because as we know, national level GDP this includes a more diversified industrial base covering mining, services, and other sectors, while provincial level output is more heavily dependent on agriculture and livestock. So here, another important findings of our study is that we're seeing that at the real GDP per capita, precipitation has a negative impact. But then, if you zoom in on the province level output, that's where we see the positive impact of precipitation, because as we know, provincial level output is more dependent on agriculture. And this is one of the novel contributions of our study, because in the paper of Acevedo et al., it actually categorized Mongolia as a low-income developing country with a median precipitation of 1,100 millimeters. However, historically, since 1901 up to present, the average precipitation of Mongolia is only 250 millimeters. So it's really an outlier if you place it along with, although economically speaking, Mongolia is a low-income developing country. But we know that most LIDCs are African nations and Asian countries that are at a hotter region in the climate. So in the paper of Acevedo, they failed to establish any robust results between precipitation and economic output. But if we look at the specific case of Mongolia, wherein it is an arid country, it will really benefit for higher precipitation. And then next is that we're not seeing any impact on agriculture at quarterly level. And one key explanation for this is that we know that livestock is a key output of agriculture, and herders can employ adaptive practices like seasonal migrations. That's why we're not getting any statistically significant result here. But for services, there is a higher temperature can actually boost services output upon impact or contemporaneously, but eventually it will have a persistent negative effect. And in terms of construction, we see that higher precipitation levels can actually decrease construction. And this is very much consistent with what we have in literature, that more rainfall can actually delay construction. And we're seeing that in our results. And another one is manufacturing. We see that higher precipitation has positive impact on manufacturing. And the possible explanation for this is that in Mongolia, manufacturing is mostly centered on processing of raw materials from livestock. And as we will see later on, livestock can benefit from higher precipitation, which can lead for more inputs to manufacturing. And lastly here, we see that higher temperature can actually have a positive impact on mining, particularly for small-scale miners, because higher temperature can make it easier for them to extract the minerals. So here we're seeing the impact of higher precipitation on livestock. Initially, it's positive, but then it will have a persistent negative effect. And here we're seeing also the positive impact of precipitation on livestock. So this is the national level, but then at the national level, we're seeing that this is the national head count of livestock. We're seeing that both precipitation shocks and temperature shocks can negatively affect head count of livestock. So these results are actually robust, regardless of different fixed effect structure that we use, the inclusion of disaster variable, and different sample sizes. So overall, what we're trying to show in our results is that while we have already established a relationship between temperature or weather and economic outcomes based on the global sample works of Acevedo et al., the specific case of Mongolia tells us that there is a value into looking into specific country studies and taking in consideration their climate context and the sector that is most important for them or unique to their economic structure. Like in the case of Mongolia, livestock is quite important for this economy. And of course, this kind of findings can no longer be captured by a more global sample or a panel data studies that rely more on panel data covering, let's say, 100 countries. So this ends our presentation of the paper, and we look forward. Thank you so much for your attention, and we look forward to the discussions and your feedback.
Thanks, Dottie, Homer, and Kara for sharing with us the preliminary results of your research. So we heard about the differentiated impacts across sectors according to national, provincial levels. So at this point, let's hear from our discussants what their views are, their thoughts on the value addition of this research work, and its implications both at the policy and investment level. So for our discussants, I'd like to introduce to you Enk Amgalan Chile, or Enki. She's a senior climate change officer of CCSD and supporting Mongolia's operations in the resident mission. Enki, what could be some of the policy implications of the findings you think both at the national and the local level? Could you share with us? Enki? Oh, I think she's frozen. So there's a connection issue with Enki. So maybe we can move forward first to Ed Faver. Ed? So Ed is the senior country economist for Mongolia Resident Mission. He has been the country economist since 2022, where he leads ADB's efforts in economic strategy and country programming. And prior to this, he was a country economist for PNG. So for you, Ed, what you think could be the economic and investment implications based on the findings of this research work, and how could we integrate the findings in the upcoming CPS for the country? Over to you, Ed.
Thank you, Sugar, and good morning, everybody. Ed Faber, based in Mongolia Resident Mission. Thank you for this valuable research, which definitely is useful to have this data to underpin some of our discussions with the government in this whole area of climate change and relation to our country partnership strategy. I wanted to share some kind of broad areas of thoughts around the implications both on the economic side and investment side. So I think we heard about the significant impact that these ZUTs can have. And as was mentioned, we had Zud in the last winter here, which affected over 200,000 people and had an impact on GDP of about 1 to 2 percentage points. And then the previous major Zud was in 2010, when about 1/4 of the livestock population was wiped out, impacting about 770,000 people, which is basically the rural population. There's about 25% of people live in rural Mongolia, and that Zud had about a 2 to 3 percentage points impact. So certainly there's a big impact on households. Just to give you an example, we visited a herding community, and one of the herders in the recent winter told us that he had lost up to kind of 70% of his flock, reducing it from around 500 to 600 to under 200, and that then it becomes difficult in terms of being able to continue with their lifestyle, generate income. There's a certain level of 100 or 150 in terms of the number of head of livestock. Once the number goes below that, it's quite difficult for herders to continue to sustain income. What they often then may do is sell their remaining livestock, and then we see a lot of this rural to urban migration. And in fact, if we look at poverty in Mongolia, the rural poverty is now estimated at about 40% as of the end of 2022, up from 30% a year earlier. And this compares to a level of 27% in the urban areas. So we see higher poverty and greater vulnerability in rural areas. Then we see the impact on the macroeconomy. There's, for example, inflationary impacts. Meat prices spiked by about 20% last year. So this in turn has effects for consumers, less money to spend elsewhere in the economy. It also has effects on, for example, monetary policy. We see that the current inflation rate is about 6% in Mongolia, but the central bank policy rate is about 10%. It's come down from 13%, but impacts such as these on agriculture and meat prices and other inflationary impacts, it reduces the scope for central bank to reduce policy rates. And then there are, of course, fiscal impacts. So there are significant demands on the government to provide support, which could be in the form of emergency aid, cash transfers, food or fodder or shelter. The last Sud had an estimated cost of about $14 million, but development partners also provided assistance. And a third kind of area for consideration is around financial linkages, so that many herders have loans which they use their livestock as collateral, and those loans they're seasonal. But when they lose their livestock, we see defaults, and there's a knock on to the financial system. So clearly there's obviously a need for significant investment, and Mongolia is targeting, there's a climate finance gap of at least 11.5 billion for Mongolia, $11.5 billion by 2030. I mean, that relates to Mongolia's nationally determined contributions, which is obviously also mitigation, but there's also significant adaptation within that. And ADB has also been trying to scale up its own climate investments. For example, last year, about $78 million worth of ADB's investments in Mongolia were tagged as climate finance. And this year we're on track for 150 million, which is about 40% of the overall envelope. And to give you an example, one project would be the AMAGS and SUMS, AMAGS is province and SUMS is district, AMAGS and SUMS Green Regional Development Investment Program. This has been supporting provincial centres for example, strengthening of infrastructure to make sure it's climate resilient to extreme weather events. It's been looking at supporting irrigation for pasture land management, and also carbon sequestration advice and techniques, and general kind of sustainable practices, as well as support for agribusinesses and livelihoods. And to give you another example of a project would be the GER Areas Development Investment Program, which is based here in, which is focused on Ulaanbaatar. And the GER areas are the informal settlements around Ulaanbaatar, where the more vulnerable population live, especially, for example, along rivers. There's no flood protection. So ADB has a project which has been putting in roads which are elevated, providing flood protection to protect those kind of more vulnerable population. So significant investments, and not just from that are needed from all sides, including private sector. So, for example, Mongolia has an ambition with its green loans to scale it up to about 10% of all loans by 2030, from the current level of about 3%. There's also need for kind of more insurance to support the herders. So that's just a flavor of the kind of economic and investment implications. And certainly, yeah, thank you again for this, for all the research, and this will also be invaluable for our developing the country partnership strategy. Thank you.
Thanks, Ed. I see that Enki is now back online. Enki, what do you think are some of the policy implications of this research work?
Sorry for the interruption, and yeah, thank you very much. It's a very interesting research. I have also met while I was in headquarters with Dorothy, and we exchanged. Yeah, I've shared some of the contextual information about, because Mongolia is one of the countries that is the most affected, I think, by climate change. The climate temperature is already 2.2%, 2.25 Celsius higher, which is like almost above the world average. So this 1% temperature rise and 1% increase of precipitation is quite relevant in terms of the implications for Mongolia. So what is the added value of this research to Mongolia at the macro policy level? I think that I really appreciate that this research also kind of now sheds light on some, like Mongolia is actually a very cold season country. We have 4 seasons. In winter, it gets very cold, like -50. In summer, it's almost plus 35. We live in such a extreme climatic situation. So because of that, the climate change also has a quite, I would say, like unique effect in Mongolia. So we also, I think that it's a high time that we take those climate shocks into consideration at the macroeconomic and macro social, not only economics, but at the social, how to protect the vulnerable people out of these weather shocks. So I think that this having this research to use Mongolia as a case is, I think it has a higher relevance. And I think it was, I would like also say thank you to the team that choosing Mongolia as your case, because Mongolia is only 3.5 million population, a small country, but we have a very big territory. And Mongolia actually is sandwiched between two big neighbors, and we don't have access to the sea. And because of that, it actually creates very unique, very continental, harsh climate. This precipitation is also one of the how to say highlights where we have such a low precipitation. It's very difficult for Mongolia to engage, especially in a crop production. We have very short growing season. That brings to the issue about, like, because if there are like some positive impact, especially in terms of increasing precipitation, which is the case in Mongolia, we can see that actually in summer we have more precipitation, although there is a shift in terms of the distribution of the rainfall. We used to have a rain like in May. This would also affect the growing season. Now we see that actually the first rain comes in June. and it goes until end of like October. So the growing season is also changing, but in terms of the length that local experts said, actually the growing season is becoming longer. So this would bring definitely the positive effect in terms of rangeland productivity, also for small scale farmers and these miners and so on. So I think that this research also kind of um, can brings up this question about discussing what are the positive impact of the some of the climate change and how we can capitalize on that, how can we put it into the policy implication, so that especially in terms of the supporting and providing the support to the herders, so that that they're actually aware of this change and then also adjust the herding practices. And these are the two very important implications at a macroeconomic level. And also, I would like to say that because we've been exchanging with Dorothy about the specifics of our country, that Mongolia is such a big country, and because of this big country, the ecological situation varies within the country quite a lot. For example, in the Gobi Desert, which makes almost like 40% of our total territory, the annual rainfall precision only 50 millimeters. Whereas in the north, where we mainly engage in crop production, is about 400 millimeters. In the east, it's about 250. In the west, is about 150. So because of this already how to say natural climatic differences in the country, is that the agriculture practices have also evolved differently. For example, in the west, the nomadic herding have prevailed. In the north, there is a combination of crop and livestock farming, where now government supports a lot of intensive farming in the north because of the high rainfall, and there is also availability of the water. In the east, actually, it was more of that traditionally they used to grow only cattle because of the weather condition. Also, the rangeland productive is more suitable in terms of the cattle herding. In the south, we only mainly there is a camel and Kashmir goats. So this traditional, how to say, the herders' knowledge, and I would say sometimes it's a natural, how to say, nature-based solutions towards these climatic situations. And this have in a policy when we're developing policy. I think that these kind of the climatic and also ecological implications should be taken into consideration, which sectors to promote in which region, so that this would be more climate resilient, and also it would suit into the ecological, how to say, comparative advantage of the region. That would, I think this would, research would be good if, I don't, but because it's, you are based on this national, the international research, there is, in case of Mongolia, because of the language barrier, not many publications are available international, that I must say that, because of, there are lots of researches done, but because of the English and also methodological differences, many of the research findings are not really shared at international level. So if there is a possibility, that would also give some local perspective. And another implication is that I would like to also complement what Ed has mentioned about that Mongolia is trying to actually reduce its dependence on extractive industry, especially because our sole exporter is China. China is going to reduce its coal import almost by half in 250. So if our main market is in reducing the import of the coal, so but we have only some 30 years to find a solution. But some of the policymakers put a lot of significance on agriculture sector. So, but if you, there are lots of policies out there, but these policies have to take into consideration what are the climate change projections in 30 years and take into account into developing this agriculture sector. The livestock herding is actually our traditional sector, and Mongolia have been always for thousands of years been herded. We are not really a very crop farming people because we were always nomads. It's crop farming has only been introduced in 1940s, so it's very new to Mongolia. So that's why I think that it has to be also taken into account the crop farming could only be supported in those areas where there are skills available or psychologically possible, and also take into account what are the climate change, especially in terms of precipitation, because most of the farming here in Mongolia, especially small-scale farming, are rain-fed. So they really almost 100% depend on natural rainfall. And of course, as the first presentation have very rightly explained, is that nomadic herding is almost 100% depend on climate situations. So, for example, almost 100% of the feed for the livestock is from rangeland, from natural rangelands. Only the additional forage is prepared by herders only during the winter, just when that there is when the rangelands are covered by the snow, that they can feed the livestock. So they still the animals are grazed in the winter. So as Rotorota has mentioned, these locally adapted breeds are also play a significant role in terms of the cropping strategy for herders. So together, I think that I would like to say that this climatic change, very specific to the country, also has to be taken into consideration when we are thinking long-term policy change, or as we said, that when we go to more climate resilient and adaptive economy. Thank you. Thank you very much for the presentation. It was very interesting.
Thanks, Enki and Ed, for that very enlightening views. Yeah, I do agree that this kind of localized study could help inform our policymakers for a more targeted solutions, sector-specific solutions, looking at longer-term horizons. So we are now opening up our session for any comments or questions from our audience. Those who are online, if you have any questions. Charles, I see Charles has raised his hand. Charles?
Sure. Can you hear me?
Yes, we can hear you, Charles.
Okay, great. Yeah, I'm from Bogor in Indonesia. I was curious. First, thanks for a really interesting presentation, and I think we need a lot more research like this. About the specification of the equation. Now, it's been a long time since I've looked at work like this. I haven't been an economist in this lifetime, but I'm curious about the specification of climate change. So you model a 1 degree centigrade increase in temperature, and please correct me if I'm not getting this right, which normally one would see over decades. In other words, it wouldn't be a one-time shock. We almost never anywhere in the world see years in a particular region that are a full degree centigrade warmer than the prevailing trend. But then on the other hand, you model a 1 millimeter change in precipitation. Precipitation usually exhibits a lot more interannual variation. And in truth, for a country like Mongolia, 1 millimeter is well with it. It's not even close to the error bounds around any annual estimate of rainfall. And as we heard a minute ago, there are strong regional variations. I'm curious why you didn't just go with a 10% increase in rainfall or something like that, which is physically realistic and which would probably tell you more about how the system would respond. You know, any other information you can provide would be very useful. Thanks a lot. This is to any of the authors. I don't know who is most appropriate. So.
Yeah, thank you so much, Charles, for that question. So so the reason why there's a mathematical limitations that we're dealing with, why we're not using percentage, we're using levels, because if you do percentage in modeling, we need to get the logarithm. And we know that in Mongolia, there's a negative values. And if you do a log of the negative values, that's going to be undefined. But for a country like the Philippines, wherein we don't experience any negative values on temperature, we can do that in terms of percentage increases. So for the percentage increase in precipitation, I can check I'm sure there's no zero values in precipitation. So we can just do a logarithmic transformation of the precipitation and see the percentage increases. But definitely for the temperature, there's a mathematical limitation for that, given the climate context of Mongolia, because they have a negative value. So this is one of the nuances that we need to consider when we're doing country level studies. For hotter climates, you can actually do a logarithmic transformation because we never experienced negative temperature. But for the colder ones, we're limited by these mathematical constraints. So thank you so much. I will try to run the model with the logarithm of precipitation, and let's see how robust the results are.
Thanks very much.
Yes. For temperature, since Dottie mentioned about negative, we can actually use Kelvin so that all values of temperature is positive. Unfortunately, when you use Kelvin, it becomes an insignificant variable. So it gets dropped in the model, correct, Dottie? Yes.
Thanks, Charles, Dottie, and Homer for that. Any additional questions? We still have until what time we have? Until 11:15 at the most. So if you have any, yes, Belinda.
Thanks so much. This is really interesting work, and I think, yeah, looks like you've taken very robust approaches. I think you had a little bit of discussion about social impacts and particularly around economic impacts. I think obviously what we see with these changes is that they're going to most severely affect the very vulnerable people, very much people living and farming in these very rural environments and women. How much do you think you've managed to communicate the disproportionate impacts on vulnerable groups? And is there any gaps you're facing around getting proper data that's disaggregated and giving you the kind of information you need to have those findings on human well-being impacts and vulnerability?
Thank you so much for that very insightful. It's like a curveball for me because we really rely here on macroeconomic data that is readily available online through databases. So I do understand that there's gender component for this, because when I had this discussion with the gender specialist assigned to EARD, she mentioned that for services, most of the employees there are female. So if the services sector is negative, the face of the impact is female. But we're not really delving into that. And I guess this is just one of the limitations of, a cold-blooded, number-based study like this one. So that's all. What about?
Yeah, we were smiling because we were taken back to those times that we were getting data. So we have to ask Kara and the rest of Mongolia Resident Mission to, oh, can you get this? Because those data that are available online, we can actually download them supposedly, but sometimes they're in Cyrillic or the local alphabet in Mongolia. So, and even if we translate, it doesn't translate properly. So thanks for that reminder.
Maybe Enki also can share something.
Yeah, Enki, your hand is up.
If there is, I just would like to also kind of comment on like in terms of the ZOD, the human-made factor, also very country specific, because historically, like since the climate change has become very um, quite visible, herders and even the policymakers tend to claim that all ZOD and disaster is happening because of the climate change. But in case of Mongolia, is that actually the overgrazing. For example, we have about 110 million hectares of rangelands, almost like 70% of total territory is used as a livestock rangelands. And there is a so-called like carrying capacity. I hope you guys know that carrying capacity is kind of economic measurement of how many animals that 1 hectare of land can feed, yield can feed. So according to that, like Mongolian 110 million hectares of rangelands can feed only about 25 million livestock. Now we have 65 million, which is almost like 3 times higher than the rangelands can feed. And this human-made factor also kind of one of the key driving factor behind the ZOOT. Also, there is a kind of combined with the climate change, because climate change has a role to play and has a significant role to play, but human-made factor. So only recently that herders and even the policymakers accept the fact that we also have to reduce this, address the human-made factor to be more climate resilient and more adaptive. So almost like 30 years now, where there's a new regulation adopted to reduce the negative climate change effect on nomadic herding, which is also to support herders to introduce some sustainable management practices and with green loan incentives and kind of tax subsidy and so on. So at the policy level, that when we give or provide this information about the climate change, so this human-made factor, I wanted to say, also has quite a role why this was happening more frequently than before. Yeah, thank you.
Thanks, Enki. Additional questions? I think just one last question coming from me. So I'd just like to check, linking with Belinda's question on the social aspect of the study. Did you also consider the impacts of climate change towards urbanization? Because as we all know, Mongolia is, as explained earlier by Homer, the zoo is affecting most of our herders, and that with the loss of livestock, this drives our herders going to the urban areas, creating more vulnerable populations to the country itself. So I'm not sure, was this taken into account in your study on how rapid urbanization is affecting the development of the country?
So model-wise, that should be captured by the province year fixed effects because it's changing. But we can, if we have the data on urbanization per province or even at the national level, I can actually just input that. So that's a very good suggestion. And it also has good context on why we are including urbanization, because it's driving the loss of livelihoods are driving the herders to Ulaanbaatar, to more urbanized centers. So okay, yes. So that's a very good suggestion. We can just plug in an urbanization variable. At the national level, I know that it's readily available at World Bank database. So thanks for that very helpful suggestion, Sugar.
Thanks. And any additional questions? Or if you have any questions, specific questions, of course, you can always reach out to our speakers, to Dottie, Homer, and Kara.
Just to add, so again, this is a working paper. We'll be getting some publication from this and also be presenting this at the East Asia Economic Conference in Bangkok. So if you have any further suggestions on how to improve our work, that will be very much appreciated. Thank you.
Thanks everyone, to our speakers and to our discussants. And yeah, we look forward from hearing again with you on the updates of this paper, working paper, and we hope to use that as future reference in our projects, say be it in Mongolia and or other relevant countries where it is applicable. So thank you again to our who joined online, and we hope to see you again tomorrow. We have our another knowledge sharing events at 2 to 3 p.m. Where speakers will discuss new initiative aimed at accelerating climate resilience for micro, small, and medium scale enterprise through banks and microfinance institutions. So we have sent the calendar invite. So please join us again in that very interesting topic. Thank you.
Thanks, Kara. Ayan. Next session will
Thank
be in
you.